Alright, so taking a look at polynomial graphs and their end behavior, what I want to focus on with this video is just kind of making sure we understand the end behavior of these basic parent functions or parent graphs, also considered to be called power functions. So we've seen previously that this guy would be a parabola opening up. We know this guy would be a little s, like so. We know this would be basically similar to a parabola. There's more to that, but that's the basic idea. This guy would look very similar to the x cubed, and then x to the sixth would look real similar to the x squared as a rough sketch. But what I'll point out is that the real conversation we want to have from this slide is the end behavior. Is where are those arrows pointing? Let me change to a better color. Where are these arrows pointing to? So when you look at this guy, when we see certain degree functions, whether that function have an even degree, an odd degree, an even degree, an odd degree, or an even degree, what is the end behavior of those particular graphs? And more importantly, where are the arrows pointing? Not what's going on in the middle. We don't care about it. It's almost like I could take the eraser and erase this part, because I really don't care about that part. What I care about is what is the end behavior of this, let's call it parent function, or power function is also referred to as the parent or power function. Okay, so let's go on to the next slide. Let's take a look at a few. So in this case right here, we come across, and the main thing I want you to make sure we understand is that when we pull this out, is what is the power function? So before we start, remember the power function is going to be the guy with the biggest exponent. So from this guy we see that we have an x squared function. And from there we go and we say, okay, well remember, we're not really worried about, what we're worried about is the end behavior, like what's happening on the end of these spots right here, like where are those arrows ultimately pointing? So since we have an x squared function, that means that we're going to have letter C, because we have an even degree function with a positive leading coefficient. So this is an even degree with a positive leading coefficient. We go to the next one. We look at the parent or the power function, excuse me. So in this case here, the power function is negative x cubed. So we know that we're either one of these, because these are both odd degree functions. These are both even. This is the odd with a negative leading coefficient, and this is the odd with a positive leading coefficient. So in this case here, our graph would be A. And remember, what we're really looking at is the end behavior, like what are the behavior of this graph, not what's going on in the middle, but what it's ending at. The next one, x to the fourth. That's an even degree, so that my parent function is x to the fourth. I don't really care about that stuff. So I'm looking at this guy and saying I got an even degree with a positive leading coefficient, so he's going to be letter C. In this case here, we would need to go ahead and distribute that through, and so we would realize that this is actually equal to x squared minus 5x, which means that my parent function would be x squared, and my graph would be C. Or the end behavior would be similar to C. In this case right here, my parent function is x cubed, so my graph would be letter B, because I have an odd degree function with a positive leading coefficient. I would distribute this guy through. I would get x cubed plus 7x. I only care about the x cubed. That's my power function. And so once again, I would be letter B. And last but not least, when I multiply that through, I would get negative 4x cubed plus 12, and the only thing I care about is a negative 4x cubed. So I have a negative leading coefficient with an odd degree, and that would be letter A. So utilize this concept to realize, in this, I didn't put this in here, but this would be a negative leading coefficient. So it would be even degree with a negative coefficient, leading coefficient. Alright, so use that to be able to help identify the end behavior and where those arrows are pointing for each of these different power functions.